Hello friends, in my previous video we have seen the different types of voltage regulators, the general block diagram of unregulated power supplies and regulated power supplies. Then we talked about the linear voltage regulators and switched mode regulators, then different types of linear voltage regulators. Now in this video I'll be talking about the characteristics of power supplies. These are the general characteristics for any power supply, which includes voltage or load regulation, source or line regulation, minimum load resistance, output or internal resistance, and ripple rejection. I'll say output impedance or internal resistance. The most common term used is internal resistance of the power supply, and then final of course ripple rejection. So let us start with the first one, voltage or load regulation. Basically when we change the load impedance, first of all let us draw general diagram of a power supply. Suppose this is the general diagram of a power supply, where this is internal resistance, this is VDC output, and we have load resistance connected here. This is load resistance and this is output of this power supply. Fine. So when you change the load resistance, there will be change in load impedance. So when you change the load resistance, there will be change in the load current, and accordingly there will be change in drop across this. Why? Because output voltage is nothing but VDC minus I load into R in. Right? So when you change load resistance, accordingly there will be change in this, and accordingly there will be change in output voltage. So what I mean to say is, if you see output voltage, when load current is 0, the output voltage is VDC, but when you increase load current, this is load current, when you increase load current, there will be change in this, and accordingly there will be fall in the output voltage. Right? So output voltage of the power supply decreases with increase in load current or with decrease in load resistance. That decrease, suppose I have some rated current, that is I load full, that is rated load current, then I have certain voltage drop across this. So that voltage here is, suppose V full load, this is full load current, that rated current is full load current, and say this is VDC, I will say this is no load voltage, so this is no load voltage. So what I have reduction in voltage at the output terminals of the power supply. So that reduction, the percentage reduction, is called load regulation. What I mean to say is, the load regulation of a power supply, which is sometimes called voltage regulation, is defined as no load voltage minus full load voltage divided by full load voltage multiplied by 100, that is in percent. This is known as load regulation. That means percentage reduction in load voltage when load is varied from no load to full load is called load regulation or voltage regulation of a power supply. This is important characteristic of a power supply. You must remember this expression. This is very important. Fine. Similarly, we have source regulation or line regulation. Source regulation and line regulation is defined as the change in output voltage due to change in input voltage. When you change the input voltage of a power supply, the change in output voltage is called, that is source regulation or line regulation. But in terms of percent, when you say the percentage change in output voltage with change in input voltage is called line or source regulation, right? That is not a commonly used term, but this load regulation is important one. Fine. Then let us talk about minimum load resistance. Minimum load resistance is nothing but rated load resistance, which is equal to the rated load voltage divided by rated load current. That is rated load voltage divided by rated load current. Remember, current through a load cannot be more than rated value, because if current passes through a load more than the rated value of the current, that may damage the load. So load has to be, that rated load current is the maximum load current. So this is the maximum possible value. The current through a load can be less than or equal to a rated value. It cannot be more than that. So if current is always less than or equal to rated value, this resistance will be definitely what? More than or equal to this value. If this is rated value, so current can be maximum this but less than this. If it is less than this, so this will increase. So it means current through a resistance, current through a load has to be rated or less. That means impedance has to be more than some minimum value, and that is called minimum load resistance. Fine. So how do we get minimum load resistance? That is rated load voltage divided by rated load current, right? So current through a load has to be less than or equal to its rated current. Then output impedance or internal resistance. Internal resistance of a power supply is nothing but this resistance, which is internal to the power supply. Fine. So it is because of some devices of the power supply. So internal load resistance is basically, that is the resistance which is internal to the power supply, and as far as possible this should be as minimum as possible, because that results in reduction in what? That results in reduction in voltage regulation. Ideally your output voltage or load voltage should be equal to no load voltage. So ideally no load voltage should be equal to full load voltage, or we can say full load voltage should be equal to no load voltage. So ideally the voltage regulation, voltage regulation of a load of a power supply is 0. This is important point for engineering services prelims exam. Ideally internal resistance of a power supply should be 0, and therefore if it is 0, then this becomes 0, so this becomes 0. So ideally the internal resistance of a power supply should be 0, and or therefore the load regulation or voltage regulation of a power supply is ideally 0. Fine. So then let us talk about ripple rejection. What are the ripples? Ripples are basically the fluctuation in output voltage. Suppose this is the output voltage, but it may be possible that it has certain ripples, right? So ripple rejection is capability of a power supply to reject the ripples. Ideally there should not be any ripple, and ripple rejection is the that is the ratio of input voltage ripple to the output voltage ripple, right? I repeat, ripple rejection is the capability of a power supply to reject the ripples. So these are the 5 characteristics where you may be having objective type questions in engineering services prelims or in different public sector exams. As far as theoretical concepts are concerned, you don't have question in GATE, but there can be questions in engineering services based on these. There was one question in GATE that was numerical way back in 99 in electronics engineering, that was based on load regulation. You can have a look at the question. The question was, load has no voltage regulation of 30, I repeat, a load has, I repeat please, a power supply has a no load voltage of 30 volt and the full load voltage of the power supply is 25 volt, and rated load current, that is rated load current is 1 ampere. The load current rated is 1 ampere. You have to find the voltage regulation. This is voltage regulation, right? And you have to find the internal impedance of the load, that is internal resistance or internal impedance of the power supply. So I repeat, you are given no load voltage of 30 volt, you are given full load voltage of 25 volt, you are given rated current, and you have to find two parameters, one internal resistance, second voltage regulation. So for voltage regulation, how do we get? Voltage regulation of the power supply is no load voltage is how much? 30 volt. Full load voltage is how much? 25 volt, divided by full load voltage is how much? 25 volt, and that multiplied by 100. So that gives you 20%. Voltage regulation of the power supply is 20%. And internal resistance, how do we get internal resistance? Please see carefully. Voltage drop across this resistance is what? No load minus full load, that is voltage drop across this. This voltage minus this voltage drop across this, divided by rated current is nothing but internal resistance, and that is 30 minus 25 divided by 1, right? So that gives you 5 ohm, that is internal resistance. So we have got both the parameters. Internal resistance or output resistance or output impedance is 5 ohm, and voltage regulation is 20% for the given supply. That was question in way back 99 in electronics engineering, right? Now there is a small topic in power supply that is known as the power supply stabilization, right? So the power supply stabilization is what? That is basically the variation in output voltage of a power supply due to different factors. What are the factors? Please see that carefully. The output voltage of a power supply can vary because of change in load resistance. One can vary because of change in input voltage, right? Third may vary because of change in temperature, right? So there are the different factors which are responsible for variation in voltage at the output of a power supply. So the variation in power supply, variation in output voltage of a power supply is given by, I will write that, this is maybe because of what? Because of fluctuation in input voltage. So fluctuation in output voltage with respect to fluctuation in input voltage multiplied by V in, plus fluctuation in output voltage because of fluctuation in what? Fluctuation in load current multiplied by what? Multiplied by I load current, plus fluctuation in output voltage due to fluctuation in temperature multiplied by variation in temperature. This is called Taylor series expansion. Your output voltage is function of temperature. Why? Because the power supply consists of electronic devices like diodes, we have already seen, BJTs and so on. So with the change in temperature, the internal resistances of those devices will change, their characteristic will change, accordingly output voltage will change. So output voltage of a power supply is definitely function of temperature. 1. 2. We have already seen output voltage is function of input voltage, so that is going to vary with input voltage, so that varies with input voltage. And third one is, that is output voltage vary with change in load impedance or load current. So there are 3 factors where your output voltage is dependent. So this is nothing but Taylor series expansion of output voltage variations, right? So this term is called, that is this voltage stability factor. Variation in output with respect to variation in input is called voltage stability factor, or sometimes we call it as source regulation factor, right? So this is voltage stability factor, voltage stability or source regulation factor, right? Second one, this term is variation in output with respect to variation in load current. This is sometimes called output resistance, right? So that is known as output resistance. And third one is variation in output voltage with respect to variation in temperature, and this is called temperature stability factor, right? That is temperature stability factor. So output voltage stabilization basically deals with variation in output voltage due to change in temperature. That gives a factor which is known as temperature variation factor, I have explained. Then variation in output voltage due to fluctuations in input voltage, that gives you what? Source voltage regulation or source stability factor, right? And third one is, that is variation in output voltage due to variation in load current, that is nothing but output resistance of the power supply. That is how we define, right? So this completes your characteristic part and stabilization of power supply. There can be objective type questions from this topic in engineering services. You can definitely study the theoretical part on the portal, but you should remember all these points from examination point of view. So in next video, now we will start studying or seeing the series voltage regulators and shunt voltage regulators. So wait for my next video. Thank you very much for watching the video.
To watch more videos like this, subscribe. Click on the bell to turn on notifications. Click on the like button. Share.